Hey there, Math Hoppers. In this video lesson, we are going to learn how to solve quadratic functions by factoring. And in order to do that, we first need to review how to multiply two binomials. Remember that factoring simply undoes multiplication, all right? It is the opposite of multiplying. So let's review how to multiply two binomials. A binomial is simply an expression that has two terms. So both x minus 3 and x plus 5 are binomials, hence the term multiplying two binomials. And when you first learned this, no doubt you learned FOIL, which is simply an acronym that stands for first, outer, inner, last, and it's just a reminder for an order that can be used to multiply. And really, it's not about remembering what order to multiply in, it's remembering each set of terms that needs to be multiplied. So let's look at what each stands for. So F is first. The first terms mean the first terms in both expressions. It's fairly easy to get. The outer, the O stands for outer. Those are the outermost terms. So the first term in the first expression and the last term in the second expression. The I stands for inner, and so those are the innermost terms, meaning the last term in the first expression and the first term in the second expression. And the L stands for last, which is just the last term in both expressions. So let's see what this looks like when we actually do the multiplication. All right, we have x minus 3, x plus 5. Let's start with F for first. Our first terms are x times x, giving us x squared. Our outer terms are the outermost terms. So x times positive 5 gives us positive 5x. Be sure to write the plus sign in front of the 5x. Otherwise, when you have a floating 5x with no sign in front of it, it will get confusing later. Our I is inner, the innermost terms. Do not forget your signs. 5 was positive, so that was easy. But remember, this is negative 3 times x, giving us negative 3x. And now our last terms, again, negative 3 times 5 is negative 15. And we know by now that we cannot leave 5x and negative 3x like this. We have to combine like terms, and that is precisely our next step. When we combine like terms, 5x minus 3x, or 5x plus negative 3x, is 2x. So we get x squared plus 2x minus 15. This shows us that in order to factor this expression, right, in order to factor this right here, x squared plus 2x minus 15, we need factors of negative 15 that add to 2. Okay, we needed factors of negative 15, negative 3 and 5, that added to 2. Negative 3 plus 5 is 2. So, in order to factor that expression, x squared plus 2x minus 15, the last term was formed by factors. So this negative 15 right here, we formed that by factors of negative 15 and the linear coefficient. So the number multiplied to the x, that's all linear coefficient means, is formed by the sum of those two factors. So we say we need factors of negative 15 that add to 2. Negative 3 plus 5 is 2, and negative 3 times 5 is negative 15. So even though we know the answer, we're going to use this to set up our rules for factoring. First thing we're going to do is make two sets of parentheses for our linear binomials. And don't let the term linear binomials confuse you. You know we're going to get x minus 3x plus 5, and those are linear expressions. That's all it means. So we set up our parentheses. Let's break up x squared first. We're going to put x and x in each parenthesis. Remember, we needed factors of negative 15 that added to 2, so we got 5 and negative 3. We're going to put those in, and those are our factors. The two linear binomial factors that multiply to x squared plus 2x minus 15 are x plus 5 and x minus 3. That is how we factor. I would love to tell you that it's always going to be this easy, but I bet it changes a little bit. Okay, so one more time, let's make sure we've got this before we move on to a more difficult factoring. X squared became x times x. Negative 15 We had factors of negative 15 of 5 and negative 3, and they added to positive 2. Okay, that's how we factored that. That's how we broke it down. All right, that is an easy example of how to factor a quadratic expression. However, because the leading coefficient was 1, it was super easy, and it will not always be 1. So when you factor a quadratic trinomial and the number multiplied to x squared isn't 1, things are a little different. Let's look at 6x squared minus 5x minus 4. We can't simply say that we need factors of negative 4 that add to negative 5. 1, because they don't exist. And 2, because when we break it up, we have to break up 6x squared. Before, when we broke up x squared, it was really easy. It was just x and x. But now we have a 6x squared. So we can't simply say factors of negative 4 that add to negative 5, even if they did exist, because that coefficient of 6, this right here, would mess everything up. So because there are several ways to break up 6x squared, many teachers will tell you just guess and check. Just try factors and test them out and see if they work. Guess and check is literally the worst. So we're not going to do that. We're going to learn a method that will always work. And this is the method when you factor and a is not equal to 1, or you have something other than x squared. All right, the constant tells us this negative 4 is what we need factors of eventually, but they won't add up to negative 5 because this 6 gets in the way. So what we're going to do is set up temporary factors. And a lot of times my kids call this the rainbow method, because I always tell them set up temporary factors by grabbing 6 and negative 4, right? So a little rainbow there. So we want factors of 6 and negative 4 that add up to negative 5. That's how we'll get the correct sum, and we will divide out the 6 later. So temporary factors are made using A and C. Remember the rainbow. 6 times negative 4. Factors of 6 times negative 4 that add up to B, negative 5. And we're going to put those factors in with x and x just for now. All right, so factors of negative 24 that add up to negative 5 would be negative 8 and 3. So we're going to use negative 8 and 3 along with x and x to set up temporary factors. And that looks like this: x minus 8, x plus 3. Clearly, these are not our final factors. X times x is not 6x squared, and negative 8 times 3 is not negative 4. So remember, these are temporary. They're temporary because we multiplied by too many things. We multiplied by 1 too much. Like this 6, we don't need. We needed it for the sum. Now we got to get rid of it. So we're going to divide out that 6. When we do that, we're going to have to simplify. X minus 8 sixths times x plus 3 sixths, we can definitely do something with that. Let's simplify our fractions, and we get x minus 4 thirds times x plus 1/2. And I know what you're thinking. We didn't have fractions before, now we have fractions. This is the worst. It's getting worse, not better. But these fractions are actually helpful. Anything that's left in the denominator simply becomes the leading coefficient for that factor. So this 3 moves up to be the coefficient, and this 2 comes up to be the leading coefficient. And our final factors are 3x minus 4 and 2x plus 1. Pretty easy, and we didn't have to guess and check. So remember that this lesson was on solving quadratics by factoring, and so far we've just reviewed factoring and multiplying for that matter. So if you can factor a quadratic trinomial, you can solve a quadratic equation by factoring, because the difficult part is factoring. Let's solve x squared minus x minus 12 equals 0 by factoring. Now we actually can solve it because we have an equation, right? We have equals 0, so we couldn't solve an expression before, but this we can. And we're going to solve this by just dealing with the left-hand side. We're going to ignore the equals 0 for now. So we're going to factor just like before, and we need factors of negative 12 that add up to negative 1. And that's going to be negative 4 and positive 3. So we have x minus 4 times x plus 3 equals 0. Now there's a property that we really very rarely think of in math because it's sort of pretty simplistic, but it's going to help us here. The zero product property states that if you have two numbers and they're multiplied together and they get 0, so a times b equals 0, that means either a or b or both are equal to 0, Remember, anything times 0 is 0. So we're going to use that in solving this quadratic. We are going to say, well, okay, if x minus 4 times x plus 3 equals 0, then either x minus 4 or x plus 3 or both equal 0. So we're going to set them equal to 0 and solve for x. So x minus 4 equals 0, x plus 3 equals 0, and now we can simply solve these one at a time. Add 4 to both sides, x equals 4. For the next equation, subtract 3 from both sides, x equals negative 3. Your solutions to this equation are 4 and negative 3. Important to note, these are factors, okay? When you did this step, you got the factors of this quadratic equation. These are solutions. Remember that our solutions are the x-intercepts, or the zeros, or the roots. There is a difference. Factors, solutions. The solutions here are 4 and negative 3. Let's solve 8x squared minus 2x minus 3 equals 0 by factoring. So we solved one where the coefficient of x squared was 1. Let's solve one where it's not. We're going to take just the left-hand side, just like we did before. We need factors of negative 24 that add up to negative 2. We're going to make temporary factors using negative 6 and 4. Remember, temporary factors, it's going to be x and x, and we'll take care of it later. So we get x minus 6 times x plus 4 equals 0. All right, we have to take care of that extra 8 we multiplied by. And we're going to do that by dividing out both factors by that 8. When we do that, we get x minus 6/8 times x plus 4/8 equals 0. We have to simplify. We're not going to leave it like that. We get x minus 3/4 times x plus 1/2 equals 0. Remember, those denominators may look scary, but you're just going to grab them and make them the leading coefficients. So our factors are 4x minus 3 times 2x plus 1. Now we can set both factors equal to 0. So 4x minus 3 equals 0 and 2x plus 1 equals 0. Let's solve 4x minus 3 equals 0 first. We are going to, let's see if I have a pointer here. We are going to add 3 to both sides. We'll get 4x equals 3. Divide by 4, x equals 3/4. Solving the next one, subtract 1 from both sides. 2x equals negative 1. Divide by 2, x equals negative 1/2. Our solutions are 3/4 and negative 1/2. Let's solve one that's not automatically in standard form. Remember that a quadratic equation in standard form is set equal to 0. Notice this is not in standard form, and that's not really too bad. It looks weird when you first encounter it, but all you have to do is put it in standard form. So make it equal 0 by subtracting 10 from both sides. Remember that you have to have like terms in order to add or subtract, so you cannot take 10 from 11n or 6n squared. So when we do this, we get 6n squared minus 11n minus 10 equals 0. We're going to factor like we have been. We need factors of negative 60 that add up to negative 11. That's going to be negative 15 and positive 4. Make those temporary factors, n minus 15 times n plus 4. Now remember, these are temporary. We multiplied by that 6 that we have to divide out. Divide out the 6 from both factors. We get n minus 5/2 times n plus 2/3. I have circled the denominators. Hopefully you remember what to do with them already. Make them your leading coefficients. And our factors are 2n minus 5 and 3n plus 2. Remember, we haven't solved. We have our factors. We have to set each factor equal to 0. Adding, we're going to start with 2n minus 5 equals 0. We'll add 5 to both sides. We get 2n equals 5. Divide by 2. We get n equals 5/2. Moving on to the next one. We're going to subtract 2 from both sides. 3n equals negative 2. Divide by 3, n equals negative 2/3. All right, I would love to tell you that all quadratic equations can be solved by factoring, but in fact they cannot. So when will factoring not work? Well, factoring won't work if you have a leading coefficient of 1, so you have just an x squared, and you don't have any factors of c that add up to b. There are no factors of positive 1 that add up to negative 3, because all we have is 1 times 1. So in this case, you cannot factor this expression, therefore you cannot solve this equation by factoring. You can also not factor if you have a leading coefficient that isn't 1, and there are no factors of a times c. Remember that rainbow? There are no factors of 2 times 1, which is 2, that add up to -7. Therefore, this expression cannot be factored, and this equation cannot be solved by factoring. In these cases, you are going to use the quadratic formula or completing the square. But good news for you, that's a lesson for another day. Remember, you should be subscribed to our YouTube channel. If you're working through something in class or maybe a quiz in one of these lessons and you just get stuck, send those problems to us and we will make a custom video solution to help you out. Until next time, Math Hoppers, take it easy.